The last example we'll cover here is a safe dosage calculation. Safe dosages need to be completed prior to administering some medications, and they're commonly based on the patient's body weight. So the first step is to determine the patient's weight in kilograms, and you'll often see the dosage ranges that are safe expressed in a couple different ways. You'll see them here. So we could see them in milligrams per kilogram per day or per dose. So what's odd about this is the particular double slash here makes it seem as though we can write this as milligram per kilogram per day or dosage. So this is sort of a complex fraction in essence. If I were to put some numbers to it, we might say that we have 1 milligram per 2 kilograms per 3 days, let's say. A function of how fraction division works means that we can actually rewrite this as the product of 1 milligram per 2 kilograms times the reciprocal 1 over 3 days. And what this helps us do is actually rewrite the expression in a more succinct manner that is helpful for our calculations. So one way in which we can combine that right-hand side of the equation is just to, and I'll erase some of this nonsense, is to reimagine the denominators put together. So we would end up with here 1 milligram per 2 kilograms per 3 days. So the format that you see here is what we'll end up using, where we have actually 2 units in our denominator if that becomes necessary. And we can use this, as I said, to keep the structure of our problem similar to the other examples that we've seen. So here's our last example here on safe dosages. We're asked to give an order of gentamicin 50 milligrams intravenously every 8 hours for a child weighing 40 pounds. The recommended dosage for a child is 6 to 7.5 milligrams per kilogram each day, and we're dividing this quarterly. Into 8-hour segments. So we're asked basically, is this dosage safe? So let's talk about safety here for just a moment. I want to draw out a little bit about what is going on inside the body here for just a second. Over time, we're increasing the concentration of the solution, whatever the order happens to be. So we have sort of a minimum amount in this case that we would consider effective. So over time, we want the concentration to meet this minimum value to actually create some therapeutic effect. So anything below that concentration really has zero effect on the patient. However, we also have the opposite, where we have a limit as to how much we want to actually include before there's some toxicity problems or something of that nature. So the other bar here that we might show is the maximum concentration level. We don't want to go beyond this. So the space between there is what we would call the therapeutic window. So as we do our injection or IV, we see an increase in the concentration. We want it to level out, and as the body expels that particular order, we'll see a drop in the concentration over time. So while it's between those particular windows is when we would say that it's having some effect, and that's what we want to be concerned with here is, are we meeting the minimum and maximum thresholds and staying within that window? So for the calculation here, we actually will need to do twice the computation. So what are we trying to find? Let's go through our 5 steps here. We want to find the dosage, right? In other words, what is the amount of milligrams per dose that we're going to introduce? And we need to compare that with what is actually being given here. So for each particular IV session, we're having 50 milligrams administered. So we start again with our desired calculation here for the milligrams per dose. And let's start with now what we know, which is the 40-pound patient. And let's do our conversion first. We have for every 1 kilogram, 2.2 pounds. Next, we need to include either our minimum or maximum recommended dosage for this particular medication. So for this calculation, likely we're really interested in making sure that we don't go over the max for this particular uh, order. So we may include the minimum as well for some calculations, just to make sure that we are having the appropriate effect. But for this calculation, we'll just look at the max and make a comparison to our order. So what that tells me is that I need to be considering the 7.5 milligrams per kilogram day calculation like this. So again, this is spread out every 8 hours. And so we need to consider as well some of the other facets of our units. So for right now, we can kind of see that pounds will cancel, leaving me with kilograms. Our recommended dosage will eliminate the unit for kilograms, but I still have milligrams per day, and we really prefer milligrams per dose. So we need to include some other conversion factors here. So for instance, every 1 day is going to have 24 hours, and every 8 hours we're going to have 1 dose. So with those units included now, those conversions included, we'll eliminate the day unit, hour unit, leaving me with my desired unit of milligrams per dose. So if we do the computation here, what we'll find is that we end up with a repeating decimal actually. So we end up with 45.45 repeating milligrams given per dose. So again, this is the maximum amount we want to give at any particular time. So when we make the comparison here to what the order is giving us, we're asked to include 50 milligrams, which actually exceeds the maximum amount, right? So is this dosage ordered safe? We'd say the order is not safe. And our justification might be something like the fact that it exceeds the therapeutic window. So we would have to make the comment here that this order lies outside the bounds of concentration that we would prefer based on the reference to this dosage. So that's it for this presentation on dimensional analysis. I hope we've presented it in a way that convinces you that it's an effective strategy for these dosage calculations. I hope you'll use this moving forward for the rest of this course. Make sure you practice some of these for yourself, and we'll see you in the next video.